Okay, YouTube, this is my last video over operating with rational expressions, in which we're going to look at complex rational expressions. That is, rational expressions called complex fractions, because what you'll see is that you have a rational expression with rational expressions in its parts. So essentially, up here in the numerator in this expression, for instance, we have a ratio up in it and a ratio in the denominator, and it is itself a ratio of these two expressions right here. So what we want to get proficient with is how to simplify such an expression. So I've got a couple examples of what a complex rational expression might look like, but the steps we'll take to deal with these basically say that we'll subtract to get a single expression in the numerator, add to get a single expression in the denominator, I guess, and I guess you could look at this right here is what I'm referring to, but basically go ahead and do the addition or subtraction of the ratios in the numerator first and then in the denominator, and then what we'll do is we'll just go ahead and do division between the numerator and denominator. So just to show you what I mean, we'll go ahead and take a look at this first example. We've got 1 over x minus 3 halves, and that's being divided by 1 over x plus 3 fourths. What we're just going to do here is this. We're going to go ahead and subtract these two fractions on the top and make it one single expression. So when I do this, I say, well, what would my least common denominator be? Now the nice thing is these are already factored, okay? We know x is x and 2 is 2, and we say the least common denominator would just be 2 times x. So in this instance here, I would say I've got to take this times 2 on top and bottom. I'd have to take this times x on top and bottom. But what we end up with, at least on top of this ratio, on top of the whole ratio here, is some new rational expression that's over 2x, okay? And we would say that I get 2 times 1, 2, minus 3 times x. So here is our new numerator, written as a single rational expression. So now looking at this, I'd say, okay, well, what's our common denominator between x and 4? Well, it'd be the product of the two. So we have now 4 times 4 over here. We have to take this times x on top and bottom. And we dig out this new rational expression where we'd say that the common denominator is 4x. We'd say, well, 4 times 1 is 4. And we get 3 times x is 3x. So now I end up with this. The thing about this is now we have a single rational expression over another single rational expression. And remember that this division bar, it really denotes division. So if we're going to do this, really our method is to just rewrite this as multiplication by the reciprocal. So we'll take the numerator expression, which was 2 minus 3x. We'll take that over 2x. This was our entire numerator expression. And instead of dividing by 4 plus 3x, that over 4x, we're going to take it times 4x over 4 plus 3x. Okay, and so what we get here is something where we would want to simplify first. I do notice that this x and this x cancel out. I notice that this here becomes a 1 and this here becomes a 2 because they share common factors, but these do not share any common factors here. So our final product essentially would be 2 minus 3x times 2. So we get 2 minus 3x, that times 2. And over here we get 1 times 4 plus 3x, where 1 times anything is itself. So as our final step here, it is appropriate to go ahead and distribute this if you'd like. We don't have to, but we say 4 minus 6x over 4 plus 3x. As a matter of fact, it's okay to leave it factored. It just goes to show that we can see that it shares no common factors top and bottom. Now, for the second example, what I'm actually going to do is I'm going to make a suggestion. We could do the same thing here, but what I'm going to suggest is this. Multiply both the numerator and the denominator by the least common denominator of the numerator in this particular instance, because that has the complex rational kind of mess in it. Okay, so I notice that the LCD between these two ratios here would be x plus 7 and x. So the idea is this. If I were to take now everything here, x plus 7 times x, on top times x plus 7 times x, take everything on bottom times x plus 7 times x, what I want everybody to notice is essentially this. This is really, this quantity here, a 1. Anything divided by itself is 1. And what's going to happen is this is really all over 1 on top. When I multiply this through by distribution here, I notice that I'm going to get the x plus 7s to cancel out. And so what I'm left with is something that looks like this. X plus 7 cancels out. I get left with just the x, okay, times 1 here. And x times 1 is x. And we say minus. Now if I were to take x plus 7 times x over 1 times 1 over x, okay, now my x's cancel out. I'm left with x plus 7 times this 1 here. So I just get left with 1 times x plus 7 is x plus 7. And we still had that difference in front. And then the denominator is just going to look like this. Multiplying straight across, we get 7x plus 7x. And so I'm going to simplify this a little bit here. I get the top expression to come out after I distribute this as being adding a negative x and a negative 7, where the x's are going to cancel out. So I get left with negative 7 on top. On bottom, I get positive 7, x plus 7, x. And I notice also that these 7's cancel out, and I'm left with a negative 1 and a 1 here. So really we end up with this new expression that says negative 1 over, and I'm going to put the x in front, x plus 7. But that's how you would deal with complex rational expressions. Basically, just go ahead and find a common denominator for the top and do your subtraction or addition. Do the same thing on the bottom. Once you get these expressions, we'll rewrite it as multiplication by the reciprocal, or we could just take everything on top and bottom times the LCD of wherever that complex ratio mess is going on. Cheers.